So I'm just in the late stages of a cold, so I'm going to try to hold it together for my presentation. Always a good thing to do. We're trying a few different things and going back and forth, so we'll see how it works tonight. I'm doing the sky this month, and this particular month has got 6 weeks. I counted them up. Because our next meeting is actually on January the 24th. So there are good things and bad things about trying to do astronomy in this time of year. Lots of darkness, bright constellations, days off work or school, holidays. But the bad thing is, as you even see outside today, the weather. It's very unpredictable and it's not very favorable. And people have many other events and commitments, so they don't necessarily have time. So I kind of set this presentation up to give you ideas that you can do, like without a lot of overhead, being able to see stuff just visually or using binoculars, just grab and go. So as far as day and night goes, we just completed the period of earliest sunset. Then we're coming up to the longest night, which is about 11.5 hours of full darkness. That's not twilight, that's actual darkness. And over 15 hours of no sun, which includes some twilight. So you could actually feasibly go out and observe for 2 hours, get 8 hours of sleep, and get up and observe for an hour and a half, all in perfect darkness. Latest sunrises come at the start of January, but that's actually a little bit asterisk because actually the latest sunrise we had was on that Saturday before we switched to daylight savings time, but not by much. The point I'm trying to make is very likely we'll be out after dark, or when it's dark, either in the morning because we have to leave early, at night when we leave work or school, it's dark. So I encourage everyone to look up, and I'm going to give some ideas of things to look at because this way you can actually do it while you're outside and if it's clear. So in terms of darkness, there's I don't know if people are familiar with the website timeanddate.com. I always find it quite useful. So you can look on dateandtime.com, and the actual URL, actually you can read it easier up there. If you go to /sun/Canada/Toronto, you get this thing, and it's kind of neat. Oops. So this is actually a pull one, so you can find out exactly when twilight is, when darkness is, when the sunrise is for any time. So as I drag it across, you can see it gives all that information, which is kind of fun to play with. That's how I can say that the latest sunrise is actually over here on that last day. And you can see how we're in the very pinched part where there's not much day and a lot of night. Just while we're here, there are other useful things on this website. If you go to moonrise and moonset, again, it's for Toronto, and you can probably enter any location. And you get like super detailed stuff. Even the Observer's Handbook doesn't cover it, especially for your particular location. So I can tell that today the moon rose at 2:25 p.m. and it'll set tomorrow morning at 8:25 p.m. The phase, everything. So it's kind of a neat website, and I go there just to check things out quite a bit. So that's why I'm mentioning this. Okay, so first thing to note, meteor showers, the Geminids are tonight. They're bright, supposedly up to 120 per hour according to space.com. The moon won't interfere, but the sky, as we saw coming in, is not so good. I just included the current clear sky chart for the DDO, and you can see it's no good until like 5 a.m. when it turns clear tomorrow morning. So maybe if people are up early in the morning, take a look up. The moon is out, but it's a very thin crescent, so it's not going to be too much of a problem. Maybe you'll have a chance to catch some meteors. The moon. This was actually Blog TO's post for on the same day that we had our annual general meeting, so they really like to have their very exciting headlines. Everything's iconic and curated and responsibly sourced. What they're referring to is the fact that the December full moon was a super moon, all the big hype about that. And January's 1st is pretty big too, and the one on January 31st is also pretty big, so hey, it's iconic triple supermoon set to rise over Toronto skies. I thought that was a neat thing to look at. So the major moon phases that we're dealing with, December 18th is the new moon. According to wherever I picked that up, it's the micro moon, and that's because if it's a super moon at full moon, it's going to be really far away. When it's a new moon, it's very small, but you don't see it anyway. First quarter is December 26th, Boxing Day. January 1st, 9:24 p.m., full moon, another super moon, also called the wolf moon. Then we're into third quarter, new moon on January 16th. And then for, I guess, the next meeting, there's a total lunar eclipse. But unfortunately, because the moon is totally full at 8:26 a.m., by that time the sun is actually up in Toronto, so we only see the beginning phases of it and we don't see the totality from Toronto. You'd have to go west. This is another website that I like to look at because I find sometimes the moon phases don't quite make a lot of sense in my head, and having the picture of what the moon actually looks like on every day is kind of neat. So the thing I'll point out, obviously I took the screenshot yesterday. Today the moon's going to be like that, so like I say, if it's clear early in the morning, you might be able to see some meteors. This is also a good time, right through here, to see the really waning crescent moon, almost before new moon, because, I mean, people see the new moon and early crescent moon in the evenings all the time, but to see this in summer, you'd have to be up at, I don't know, 3 a.m., whereas now you can go out at 6:30 in the morning, and you can see it quite far up in the sky. And if you want to observe anything, I don't know, I didn't study the observing certificate for the moon, but if there's stuff on that limb, this is a good time to observe that. Same thing out here. As we get close to the new moon, you can check out, and that's in January 14th and 15th, and kind of mid-January. So the moon does do a few tricks. There's an occultation of Aldebaran. Unfortunately, the moon is almost full, so I think the light from the moon is going to make it a little bit less spectacular, but the dark edge of it will occult it, and in Toronto that'll be at 6:21 p.m. And just the dark edge will be going across Aldebaran, and then at 7:19 p.m. it'll reappear. So it's nicely placed in time. What you'll see is there's not much stuff that happens in the early evening, but this is one of them. Then there's the total lunar eclipse, which is also the blue moon, second full moon in January. I'm sure we'll hear all kinds of hype, and it's a super moon and who knows what all. But the moon sets from Toronto before total eclipse. And I assume that everyone who's a RASC member gets Sky News, and these things are covered in Sky News, so you can look it up there, November, December, January, February, respectively. So the interesting thing about the January 1st full moon is that it's 66 degrees high in the sky. And I actually got that from that time and date. I just kind of poked through there. And it's the highest full moon in our sky since December 10th, 2011. And also it's a supermoon, so that's kind of neat. But because the moon's orbit wobbles around the Earth, it will actually have higher and higher full moons around this winter solstice until about the top highest might be on December 14th, 2024. So it will be higher, but this is the highest it's been for quite some time. So I would say that if January 1st in the evening it's clear and crisp, and the snow's on the ground, which sure looks like it's going to be, get out into the country and take a walk under the moonlight. I mean, you can't really observe, but it's quite magical walking under the full moon, the snow, the stars. I mean, the stars are bright enough in winter that you will actually see them. So it's another astronomical experience that you can have, I think. So planets, what are the planets doing? All the bright planet action is in the pre-dawn sky, so you're going to have to get up early, but not too early because it is winter. There are two interesting conjunctions coming up. You can use a telescope to view Uranus in the evening sky, and it'll It's kind of on the meridian due south that when it starts getting dark. And you can view Mercury in the morning sky. I don't know that people are necessarily using a telescope. It's not a great view, but it never is a great view. Other planets will be better positioned for serious observation later in 2018. Venus is gone. It's behind the sun. It'll reappear as an evening star in 2018. And Pluto is also behind the sun. I'm still bitter that Pluto isn't a planet, so I included it, but you can't see it anyway. So right now it's just giving us the current time. What I'm going to do is I'm going to move time ahead. It's not stopping time. There, time has stopped. So this is tomorrow morning at about 7 a.m., or sorry, 6 a.m. from Toronto. South is there, east is there. So you see Mars, Jupiter, and the moon. It's an okay grouping. I mean, you can go out and have a look if it's clear, and the clear sky clock does in fact say that, and catch some meteors. So I'm going to step through the days and we'll see how things behave. So the moon zips out of sight very quickly in this, and you'll see it kind of pop in and out. You can see that Mars, Jupiter kind of gets higher and higher in the sky at the same time, while Mars is in retrograde motion, so it's moving along in the other direction. So now we're at the 1st, 2nd, 3rd, 4th, getting pretty close. 5th, 6th. So just, let's select an object. So there's Jupiter. If I center it on Callisto, there's Mars. And that eyepiece is a half-degree field of view, which is basically the size of the moon. So those are close together. They're equally close together on the 7th, only Mars has kind of moved a little bit below that. This one's easier to show in stellarium like this. So those 2 days, both days for us, the moon and Mars are like a 1/4 degree apart, maybe 1/3 of a degree apart. I would say if you've got a telescope, this is worth taking a look at because a low-power eyepiece will get both of them. But even in binoculars, it should be good. Naked eye, I'm looking forward to seeing it. I don't know quite how it will look. Mars is not as bright. Jupiter is going to be obvious. Mars may be a little bit harder compared to the brightness of Jupiter. If we get out of this, actually, we zoom in on this. So we see that Jupiter, again, I have to look up here. Its magnitude is -1.83, so there's no problem seeing it. But at the same time, Mars' magnitude is 1.44. It's quite a lot dimmer. So, like I say, we'll see. Let's go back to about the regular kind of full sky field of view and step on. So there's one other event that happens, and again, this is in Sky News, which is the moon joins Mars and Jupiter, and that's on the morning of the 11th of January. So there's another kind of photo op. Mars is a bit further from Jupiter. It's gotten a little bit brighter and a little bit, I don't think it's any higher actually. So there's another photo op. And then as time goes on, they actually separate. And we're approaching, by the way, that's Scorpius, that's Antares right there. So it's actually heading into the summer constellations. So I'm going to go back to, I'm going to go back.
What's it supposed to be? Is it
6 a.m. That's 6 a.m. Well, 6 a.m. is just the time that I stopped it at to step it through. Okay. So obviously at 6:15 it's going to be a bit higher, but the light will be starting. Yeah, if you went out at 5:30, it would be lower. 6 o'clock seems like an appropriate time.
It's in the morning.
Yeah, morning. All bright planet action is in the morning. Have to get up early.
I don't do that.
Well, you're going to miss out then. So I'm going to set it to 7 a.m. now, and we're back to and what I'm going to do is I'm going to well, Mercury, and actually today Mercury is in inferior conjunction. It's between us and the sun, but it's a zippy little planet. So even though it's right by the sun right now, it's not really going to be a problem, as you will see. So the 14th, 15th, 16th, popping up from the horizon, 17th, 18th. The fatter the dot looks, the easier it will be to see. So that's not too bad. That's if you're not doing anything on the morning of the 25th, that would be a good time to go out and take a look. It's magnitude -7, so that's pretty good. And in fact, all through to about the end of December, it's good. Then it starts dropping back down. But the next thing that happens is on the 12th and the 13th, it meets Saturn. And I would say that you want to try to, wrong way. I would say you want to try to look for it on the 12th because you're going to see Mercury. Saturn's going to be a lot harder to see. Mercury is going to be your guidepost, and it's dropping down very quickly and also getting fainter. So if you have a chance to go out on the 13th, on the 12th, sorry, go and take a look. This is at 7 a.m., and you can see that it's quite low. Its altitude is 4 degrees. So if you remember the old trick of holding out your hand like this, it's like a knuckle and a half up. So you need a low horizon. But Mercury will be bright enough to be seen, assuming it's clear. Okay, so Mercury is best viewed in late December, reasonably high, 7 a.m.-ish, east-southeast. Jupiter aligns with Mars in the early dawn sky. Is the moon in the 7th house? I don't know. The old people got it. Moon, Mars, and Jupiter are together in the early dawn of Thursday, January the 11th. And Mercury and Saturn close together Friday, January 12th, and Saturday the 13th. And again, if you look in your copy of Sky News, the best things to see, it's all in there. Okay, for stars and constellations that you can see, late December evening, actually, the summer triangle is still visible. It's setting, but it's up. Setting in the east, and Orion is, it's setting in the west, good heavens. And Orion is rising in the east. And because the nights are long, they actually end with Orion having already set and Vega and Deneb coming up in the east again. So I'm going to introduce something that stood out for me for a while, and I call it the winter arc, but it's maybe not the greatest name. It's the name I kind of think of it. The stars Capella, which is the brightest star in Auriga, and Menkelmann, which is the second brightest star in Auriga, and then you kind of arc over to Castor and Pollux and Gemini. You go over to Procyon. It just continues this lovely arc. And you go to Sirius and Canis Major. And it's not quite so good actually early in winter, but once you get into, even springtime, at sunset, Orion is setting, and it makes this wonderful arc, and it's quite visible in the sky in the west as well. So we'll just use stellarium again I'll show you what I'm kind of talking about here, I hope. So this is again right now. Turn on some constellation markings. Oops. Oh, I know what's going on. Which one do we need? Oh, it's way down at the bottom? Okay. Okay, so the arc that I'm talking about, well, actually, I'm going to just turn off the lines and constellations a little bit. I'm going to run time forward. Oh. So there's Auriga, and this is the second Menke, whatever, is the second brightest star in Auriga. Then you follow the arc over to here, and you can come right over to here, to Procyon, and then it comes down to Sirius. And it kind of is an arc over Orion. Now I'm going to turn the constellation stuff back on. There we go. Sorry, this screen is kind of, that's better. Now, you can say, well, you know, this is not really the way that we look at things. But the interesting thing is that if you look at other cultures, they actually see different things in the sky. And, you know, on a cloudy night, you can play with stellarium and you can actually take a look at some of this. So that's actually in the star lore. If we go to, say, the Lakota, totally different. Not only do they have this arc, and they actually complete it as a full circle, and it's called the racetrack. They've got the small little Bear's Lodge, which is what we think of as Gemini. And instead of Orion being a human figure, and like every time I look at Orion, I think, oh, that's got to be a human figure, they see an animal hand. And I think it's kind of interesting to try to, 7 little girls is the Pleiades. So this is kind of another thing that you can go and look for and see whether you can see the sky in kind of different ways. And just for another example, the Polynesians also saw this arc, except they call it the Baler. And I think that you can see what importance they attach to that pattern, because if you're in a canoe in the middle of the Pacific, having a Baler on hand is probably something that you really want. If I zoom out a little bit, I'll just go back to our regular view just because it's so I'm going to just run it up to I have 5 minutes? Okay, so on January the 1st, we're talking, this is about 11 o'clock, this is what you have. Of course, it's the full moon, but all your winter constellations are up. So I'm going to also talk about a constellation, Canis Major, which is quite far south and best seen in January. It contains the brightest star in the sky and other interesting stars as well. So again, something to look at. So there's a star map, and this is actually a good one for where we are in Toronto, because our horizon is actually down about here, and this is about halfway up in the sky, this 0 degrees. So this star map actually shows you, like in that sort of arc, if you're looking due south, and Canis Major is to the due south. There's a picture that I just grabbed, kind of purporting to show what it looks like visually, except you don't see those lines very much. So Sirius is quite a bright star. It's magnitude minus 1.46. Magnitude's a tricky scale, and you think, well, you know, Sirius is bright, but there are other bright stars in the sky. Since I don't have time, I'm not going to go through all the math, but basically, here are the stars. Oops. Here are the stars in Orion that I got from Wikipedia. They have lists of stars and constellations. And you can see there's Rigel and Betelgeuse, and there's their magnitudes. So I did a calculation here and calculated how bright that star is compared to Sirius. So Rigel is about a quarter the brightness of Sirius. And basically I added everything up, I left out some rows there, to almost magnitude 5. And Orion, all of Orion's stars together make up about 90% of Sirius's brightness. If you think of it another way, you could take Sirius and split up its light, and you can make Orion, and you can probably make some dim constellation or two beyond that. Centaurus is a pretty bright constellation. That's the only one I could think of that's bright, so I did the same sort of thing. Wikipedia is great because you just copy and paste. Centaurus is a little bit brighter, but it's a honkin' huge constellation. But by the way, Sirius will be getting brighter. In 60,000 years, it'll be even brighter, and then, so what this means, why the dog is big, why it's Canis Major, it's the brightest constellation in the sky. That's why I wanted to feature it. Sirius can almost pull this off all by itself, but it does have some other stars. 5-star selection. Adhara, which is the second brightest star, it's a supergiant. It's, according to Wikipedia, the brightest ultraviolet source close to us. Ionizes lots of gas, so it's probably interesting to look at in a telescope to see if it looks blue. And about 4.7 million years ago, it shone with a magnitude of minus 3.99. That's like as bright as Venus. That would have been an incredible sight to see in our sky. Wazn, which is the next brightest star, is that's just a regular old supergiant. Mirzam, it was the brightest star about 4.4 million years ago. Apparent magnitude minus 3.65. Again, like way brighter. The comparison we did between Sirius and all these other stars in Orion, Sirius could not even compete with these stars. And this final star, it's not very bright right now, but it will be the brightest star in the sky in about 2.9 million years ago, but it's kind of sucky, minus 0.88. So we're doing pretty well right now. And I just included the map again, just to have a quick look. So Adhara, which is the one that's got the ultraviolet, is right down there. It's the rear paw. Wazn, which is delta, is the dog's the base of its tail. So Beta Mirzam, which was the brightest star, is the front paw. And then Aludra, which is Eta, is the tip of its tail right there. So Sirius is the brightest star now, but in the past, these two stars were the brightest. And that star that will be brightest in the future, I don't know where it is on this map. And the bonus object is M41, which is south of Sirius. So if you look at Sirius in binoculars, you can take a look at M41. It's a pretty easy object, nice bright stars, nice view. Just have a curious question, because Sirius is a double star, but has anyone seen that double in the telescope? No, it's very hard to see. The one interesting thing is its companion is getting further away from Sirius, and it'll be kind of the next 10 or 15 years, it'll be as favorable as it gets. I imagine it's still going to be a challenge with visually or with imaging, but that's another interesting thing about Sirius. So if I just can start up Stellarium once more just to show something else that's kind of interesting. So again, I'm going to turn on this. It's defaulting to the Lakota. That's interesting. I recognize the Lakota actually because I was going to talk about it and I'm thinking, why is it coming up right away? And we're actually going to go to the same place, but instead of that, we're going to go to the Inuit. And there's a couple of interesting things here. First of all, they actually have a little bit of the arc here, but they call it the collarbones. This is an interesting, that's Procyon. That's what we call Procyon, and they call it the name of a murdered man. And I was really intrigued by that, and I was glad that actually this current issue of Sky News covers Canis Minor, which is the star that Procyon is in, and actually gives you more details. So I encourage you to go to your Sky News and read that article and find out a little bit more about why it's called the name of a murdered man. And the final thing is, this is Sirius, and it's called flickering. And the reason it's called flickering, I think, this is my theory, but I think it's a good one, is Sirius doesn't get that high for us, but once you get, say, up to the Arctic Circle, it never gets more than 10 degrees above the horizon. So if you put out your fist like this, it's like a fist's height above the horizon. And given the cold air and the winds, it's going to be sparkling like anything. And I've experienced that personally sitting on my friend's dock, which faces north. And in the late summer, early fall, Capella is kind of scooting along the horizon. My friend goes, "That's a really flickering thing. What is that?" And I say, "It's Capella." Well, Sirius is like 5 times, 6 times brighter than Capella, so I imagine it flickers like anything, and that's what we call it, flickering. So it's kind of interesting to poke around with the different cultural things and try to kind of see different things. And when you get a chance to look up, try to remember that and say, can I see the sky in a slightly different way? So that's it. And thank you. Any questions?
Any questions for Ed? And I'm going to pass you the microphone.
Yes.
When will Pluto be visible again?
Well, because Pluto is basically not moving, like it's so far away, it basically doesn't move against the background of the stars. I'd say if you give it basically you're waiting for the sun to move away from Pluto rather than Pluto doing anything particular. So I would say, and it's going to be in the morning sky. So I would say, give it, honestly, if you wait until summer, it's probably fine, and then it'll be kind of in the sky at midnight. But it probably will take at least 3 or 4 months, and then you'll be looking for it in the early morning sky. I guess it's in Sagittarius right now, which will never get very high up either. So it's not greatly located for us.
So the signposts around it, though, are located.
Yeah, I looked at that webpage and said, well, it's a dim star, though, in a field of dim stars. One day I'll tell you our experience in trying to see Proxima Centauri in a star field with lots of stars around it. It didn't work at all because there's a billion stars, and one of them was Proxima Centauri. Yes?
When will Pluto be called a planet?
Sorry?
I said, when will Pluto be called a planet again?
Well, I understand there's still politics going on over this, and I think the original decision was political as much as anything else. So it's not really fact-based one way or another. Everyone has a point. Who knows? All right, thank you.